In this video, we're going to look at three examples of problems that use the parallelogram area formula. Recall from the previous video that the way to get the area of a parallelogram is you have a side that's the base. Perpendicular distance from base to base is called the height. Then the area is those two things multiplied together. Base times height. Let's look at this first one. So by the way, this is how I abbreviate parallelogram. It's the parallel symbol and then GM, so you'll see it a lot. This parallelogram has area of 40 square inches. How long is the segment marked with an X? So presumably these are inches. Inches, inches. So, key here is looking for this perpendicular mark, because this perpendicular mark is going to tell you where a base and a height meet. I have this line here perpendicular to this one. So this line goes along one of the sides of the parallelogram. So that must mean we are treating this side as the base. Often we draw with the base on the bottom, but there's no requirement that the base be on the bottom. Since we're treating this as the base, then that means this must be the height. And if the arrangement confuses you, if you're finding it like, oh, I wish the base was on the bottom, remember you always have the freedom to turn your paper so that the base is actually on the bottom. So we have 10 and 10, and here's the base to base distance, which is the height. So what were we told? We were told the area is 40 square inches. So this is the base, which is 10 inches. This must be the height. So we simply have the 40 square inches, which is the area, equals the base, which is 10, times the height, which is our unknown x. And so dividing by 10 means x is 4. And since we have square inches, and this is inches, it must be 4 inches. So using the perpendicular mark to tell you where a base and a height is can be an important part of some of these problems. Let's look at our next example. A parallelogram has side lengths 5 and 12, and one of its angles measures 65 degrees. What is its area? So let's recall what we learned about parallelograms at angles from last semester. I have a parallelogram. From last semester, we recall that these two angles must be congruent, the opposite angles. I'll mark them each with X. These two angles must also be congruent. I'll mark them with Y. And if they're not congruent, if they're what we called consecutive angles, then they're supplementary. So here we have a parallelogram with side lengths 5 and 12, and one of its angles measures 65 degrees. What is its area? So by telling you one angle is 65, that means this is 65, and then we can use this to get all the rest of the angles. But I don't think we're going to need to figure out all the angles on this one. So I have a parallelogram. I always like to draw, if I have the choice, one of the long sides as the base. Generally it's easier to see what's going on than with the short side as a base. So one of the side lengths is 12, another one is 5, and one of the angles is 65 degrees. Well, because these angles have to add up to 180, if one is smaller than 90, then the other has to be larger than 90. In other words, you're going to have one acute angle less than 90, and you'll have one obtuse angle which is more than 90. And so since we're given 65, that must be one of the acute angles, one of the less than 90s. So I'll put that right there. I could also have put it here. So our question is, what is its area? Well, remember, area is base times height. But we don't have a height here. We're going to call this the base. I like to have my base on the bottom. Height is base to base distance. And for problems with angles, it's almost always best to make the height over here so you get a right triangle. Because we're going to use trigonometry in order to determine what the height is. You want to be careful here. This side down here of the right triangle, we don't know this length. Sometimes students see the 12 here and mistakenly think it's right here, especially if they've been sloppy in their diagrams. We don't know this length, and we don't need to know this length in order to answer this question. We need to know what the height is. So if I label this triangle for trig using this 65-degree angle here, this of course is the hypotenuse. It's across from the right angle. And this over here is opposite. So the trigonometric ratio that connects opposite with hypotenuse is sine. So I can first, in order to find the height, I'm going to use a touch of trigonometry. So I'll have sine of the angle, 65 degrees, is opposite over hypotenuse. Opposite is the height, and the hypotenuse is 5. So to get the height here by itself, I'm going to multiply both sides by 5. So I'll get the height is 5 times whatever the sine of 65 degrees is. And if I ask my calculator, let me get my calculator here, what 5 times the sine of 65 is, it says 4.53. So the height is around 4.53. There's no units on this, so it's just 4.53. And then we can bring this over here and use this to answer the question. The base is one of the sides, so we chose the base to be 12. And now the height is around 4.53. So if I multiply those together, my calculator over here, I get 54.4 to the nearest tenth. And there's no units here, so whatever the units are, if these were inches, this would be square inches, but since there's no units, I don't write any units on this answer. So that's an example where we have to use a bit of trigonometry. Let's look at our last example. The area of a parallelogram with side lengths 10 and 20 is 160. What are the measures of the angles of the parallelogram? Alright, so in this problem we're told the area. So again, let's remind ourselves what we know about the angles of a parallelogram. Opposite angles have to be congruent, and if they're consecutive, not opposite, it will be supplementary. They'll add up to 180 degrees. So we want to know what are the measures of the 4 measures of this parallelogram, the angles of the parallelogram. What we're told is we know the side lengths are 10 and 20, and we're told the area. This is the area. So in any problem where you're told the area, it immediately becomes suspicious that you're probably going to use this formula. Instead of calculating area, we're going to use the formula to figure something else out over here. So let's draw it in our usual fashion, where we make the base the longer side. So I have 20. This, of course, would have to be 20 as well. This is 10. This would have to be 10 as well. And I know the area of this thing is 160. So again, this is going to end up being a trigonometry question. To figure out this angle, we're going to get this one. We're going to do our usual height that makes a right triangle, like so. But unlike the previous one where we had to figure out the height to get the area, now we're going to figure out the height from the area, because we know the area. It's 160. So we're going to use this formula to figure out what the height is, and then once we know 2 sides of this right triangle, we can use trigonometry to figure out what that angle is. And once we know that angle, we'll be able to use this pattern to figure out what all the angles are. So let me go through this. First, I know the area. I've chosen the base to be 20, so I can very quickly solve this for the height, and I get the height is 8. So this is 8 right here. Now I'm going to figure out this unknown angle. Let me use that Greek letter theta for angles. So again, if I label this triangle for trigonometry, this is the hypotenuse, and this is the opposite. Adjacent's down here, but it doesn't concern us here. And the trigonometric ratio that connects opposite to hypotenuse is sine again. So I write sine, I've chosen to call that angle theta, is opposite over hypotenuse, 8 over 10, which is 0.8. So to get the theta all by itself, because I just want theta, I'm going to inverse the sine away to the other side of this equation. So if I inverse the sine away, I'll get theta as inverse sine of 0.8. And this is a calculator question. Inverse sine of 0.8, 53.1 degrees roughly. And now that I know this angle, I can quickly write down the measures of all the angles of the parallelogram, following the pattern right over here. This is 53.1 degrees. This is also 53.1 degrees because opposite angles are the same. And then these angles have to add up to 180. So if I do 180 and subtract 53.1, that's going to be 126.9. So this is 126.9 degrees, as is this angle. And that's what this question was asking us to do, determine the measures of the four angles of the parallelogram.